Good day and welcome back to my training series entitled Understanding EMV. This is the 13th video in the series and we are currently in the EMV acquiring section. And this video starts off the first of a series of videos covering the EMV transaction. So let's get straight into it. Okay, so in the EMV acquiring section, let's see what's covered. We'll be covering, we've covered already what makes a terminal EMV compliant. In this particular series, we will be discussing the EMV transaction, and later on we'll look at the EMV fallback and the ISO 8583 basics. So let's get straight into the EMV transaction, and this is the first step of the transaction. Okay. I think let's start with a narrative. We've got Bob has gone off to his local comic book store and he's decided to buy a pair of socks for his wife Sally for her birthday. And so he's at the till. The purchase, has been captured on the till system, and the teller asks Bob, "So Bob, how do you like to pay for the transaction?" And so Bob says, "Obviously, I'm going to pay with my credit card." Okay, and so what we will do is we will use this narrative to sort of explain what happens from the time that Bob, first has to start processing the transaction till the time he actually, picks up his goods and walks away from the store. Okay, before we actually start with the first step of the EMV transaction, I think there's just some ground rules that we need to understand. Okay, so this section, as in all other EMV sections, under acquiring will focus primarily on the POS device. Okay, and the reason for this is that if you use a POS device as an example, we get to see a nice full spectrum of everything that happens in EMV transaction. Had we chosen to use a terminal like an ATM where terminal risk management doesn't occur, obviously it would be to our detriment. So the purpose of this video and the next set of videos covering the EMV transaction will all be, Bob attempting to make a purchase at the POS device using his card. Okay. There are two critical rules that you should understand before we start the actual transaction. The first one we refer to as the golden rule of EMV. And the golden rule of EMV states that the strictest rule always applies. Okay, and what this means is that in an EMV transaction, we always look for a reason to decline a transaction first, an AAC. And if you can't find a reason to decline a transaction, then we're going to try to send it online for an issuer host to further verify it. And so that's an ARQC. Okay, and if we don't find a reason for the transaction, to go online, then we're going to settle for an approval. Okay, which is a TC. The second rule that you need to understand before we commence is something that I call Order 66, which states that the card is queen. Okay, and what this means is that in an EMV transaction, the card is the final decision maker in terms of the authorization outcome. Okay, please note, even though the card is queen, the queen is still bound to obey the golden rule. Okay, now, these rules are my own. The golden rule of EMV and Order 66, I've just made them up. It's not an actual thing within the EMV world, but this is how I remember it best, and I found it pretty useful throughout the last 16 years or so that I've been training in EMV. Okay, so let's get straight into it. An EMV transaction is made up of the following flow. So step one is a technology selection. So let's confirm what are the hardware components that are going to be used in this transaction. So the POS device and the card, and what sort of technology between these two will be used during the transaction. Next, we have something called application selection, and so here is where we select the virtual card or the application that resides on the physical chip. And once we've committed to this, there's some sort of a data exchange between the terminal and the card, and this is known as read application data or initiate application processing. Basically, all this refers to is an exchange of relevant data between the card and the terminal. After data is exchanged, we go into an offline data authentication phase, and during this step of an EMV transaction, what happens is we actually verify, the terminal verifies the card being used is an authentic card, that it's not a counterfeit card or a clone card. Once we verify the card, we then attempt to verify the transaction. So is this transaction a valid transaction? Is it being used in the correct context? Either geographically or is the transaction type supported by this card, right? Once we've assessed whether the transaction is valid, we then have to validate whether the card holder is the authentic card holder authorized to use the card. Okay. And I know I'm going through this fairly quickly, but I'm just taking you through the basic steps. Every video will actually talk in detail through each one of these steps of an EMV transaction. Okay, so after we verify that the card holder is authentic, we then do something known as terminal risk management, right? And there are various different tags and various criteria that are assessed during this phase by the terminal, right? That's why we call it terminal risk management. If you look at some of the manuals, like the EMV Co manuals, if you look at the Mastercard, Visa, Amex manuals, you may find that the way they present the diagram, it will have the step 7 running in parallel with steps 4 to 6. Not significantly important. I prefer it this way because it's sequential and it's more logical to follow. All right. After the terminal risk management phase happens, we go into a phase known as terminal action analysis, and this is where the terminal basically recommends a course of action to the card. Remember, I'm saying recommends. And the reason for this is, remember Order 66, the card is queen, so the card makes a final decision. All that the terminal can do at this point is to make a suggestion to the card in terms of what it thinks the authorization outcome should be. Okay. Once the terminal action analysis is done, we go into the 9th phase, which is card action analysis, where the card also has a look at the various parameters and criteria and transactional what's present in the transaction to analyze what sort of authorization decision it should come to, obviously taking the terminal action analysis into account when it does this. And then we get into first gen AC. Now first gen AC is the actual decision making step. Here is where the card makes a decision. Okay, and at this point, if the card decides to either approve or decline a transaction, we would end up basically at transaction completed, right? But for the purpose of this training, just to see the full flow correctly, let's ignore that and let's take it one step further. Let's assume that the terminal decided that it needs to go online. It needs some sort of verification from the issuer host, in which case it makes a decision to send it online, which is known as an ARQC. The transaction then routes up, via the acquirer bank into whatever local switch they use to the issuer bank, and it finally reaches via the issuer switch. It will reach the issuer host system, and the issuer host system will make a decision. Right. So let's just approve it. Let's decline it. Let's further verify the card holder, whatever it may be. Okay. This decision is then sent back downstream through the route it came up. It reaches the terminal, and then the terminal passes it on to the card, and the card makes a second decision, which is now the final decision, and this is known as second gen AC, and in this case it'll either choose to either approve or decline the transaction. Once this is complete, if there are any scripts that have been passed from the issuer host system down to the card will process the scripts, it will apply the scripts, and thereafter we have transaction completion. Okay, and this 14-step flow is basically everything that happens during an EMV transaction. Okay. So let's talk about the first step. But this video covers the first step, which is technology selection. Okay. So when a chip card is presented to a POS device, it may be processed in one of three ways, right? So we've got there Bob standing at the teller, and he's looking to complete his purchase, and he's got a card, and the merchant, the comic book store, has a POS device, and so we need to figure out, what sort of technology can we select to have the card interact with the POS device to actually start and complete a transaction, right? So the first type of transaction would be a manual entry, and what a manual entry is basically where the teller manually punches in the pen of the card onto the terminal, and that's it. The card does not participate any further in the transaction. The second one is mag stripe. Fairly straightforward. You swipe the mag stripe through the card reader, and the terminal uses that for the transaction. And obviously, the third one is the one we're most interested in, which is obviously a chip or an EMV transaction. Okay. So let's talk a bit more about manual entry, and I've explained it. So basically, what happens here is Bob presents the card to the merchant, the merchant or the teller working for the merchant. So the teller says, "Okay, look, my device is only capable of manual entry, and what it means is I'm going to take your card, and I'm going to punch in the 16 characters of your pen into the terminal." Uh, and then the terminal will take the number, and it will sort of append it to a transaction, and it will send a transaction message upstream. So there's no real interaction between the card or the terminal. Okay, so the terminal takes a pen number from the user input. Obviously, the teller has punched it in. And as the terminal builds an ISO 8583 message, it will add the pen number into it into field 2, and then it may be sent online for decision, or it may be approved offline depending on the circumstances of the transaction. Okay. And obviously, this is not very safe because I mean it's easy to do this without having a physical card there. It's easy to just copy someone's card number and punch it in and complete the purchase in that way. The second technology that we could use would be magstripe, right? And so on devices that don't support chip, what we would do is we would take the card and we would swipe it, down the magstripe reader of the POS device. And what happens is when we do that, the terminal will read the data on the magstripe of the card, and literally track 1 and track 2 data, and then it builds an ISO 8583 message, and it just takes this track 1, track 2 data, it appends it or adds it to the message, and it processes the transaction. So once again, no real involvement of the card during this transaction. So it's not involved in transaction risk management in any way. Once a card has been pulled through the magstripe reader, its function is pretty much finished. It's had track 1 or track 2 read off its magstripe, and everything else then depends on the terminal in terms of completing the transaction. Just bear in mind, we did talk about service restriction codes in the EMV issuing videos. So I mean, if the card is set up with a service restriction code that indicates that it's a chip card, if you do swipe it, the terminal will say, "No, hang on, it's a chip card. Please insert the card." Right? And so typically, a service restriction code starting with a 206 indicates that this is a chip card. Okay. Right, and now we're talking about the technology that we're most interested in, which is obviously chip or EMV. And remember, for the purpose of this training, we are focusing on contact transactions, right? So I've excluded contactless or tap and go from this training. Hopefully I will do a later training course that will just sort of cover contactless in more detail. But for the purpose of this training and the purpose of this video and the next 13 or 14 videos to come, dealing with the EMV transaction, we are going to focus on a contact chip transaction. So a contact chip transaction is where you insert the card into the POS device's card reader or chip reader, and the chip is powered up by the terminal. It stays in contact with the terminal until the transaction is complete. Okay, and only once the transaction is complete do you remove the card. Okay, so what happens is when you insert the card into the device, right? There are contact pins in the terminal's card reader, which we've discussed already in previous videos. Okay, these contact points or these contact pins on the card reader will make contact with specific zones on the contact plate on the card, and we've spoken about this as well, in the EMV issuing section. Uh, the chip is then powered up through these points of contact. Okay, so basically you've you've got a POS device that has power. You put a chip in that doesn't have its own inherent power, but because there's a contact point, a contact pin uh, between the in the terminal that touches a specific zone on the contact plate in the card. This supplies power to the card. It powers the chip up, right? So it basically supplying power to this microcomputer that we know lives on this card. Okay, and once it's powered up, then it can function as a computer, and it can communicate with the POS device. Okay, I've already mentioned, for the sake of this training, let's assume that we are focusing on a contact chip transaction, and we're going to insert it into an EMV capable terminal. Okay, so that in a nutshell covers technology selection, right? So just to reiterate, we've got Bob standing at the teller. The teller says, uh, "So how would you like to make a payment?" And Bob says, "I'd like to pay with card." He takes the card and he inserts it into the POS device. The POS device supplies power to the card. The card, or the chip on the card rather, powers up, which means the microcomputer is now awake, and some sort of communication is now available between the POS and the card. Okay, so and that's basically technology selection in a nutshell. In the next video, we will be discussing application selection. So yeah, look forward to catching you guys there, and yeah, we'll chat to you guys soon. Okay, cheers, bye bye.